In this orthokeratology case, we've got a patient who's getting some double vision after treatment. After treatment, we can see that the lens is centering pretty well, and the treatment zone is pretty homogeneous, not too much variability, very little cylinder on the cornea. And if we look at the lens, the baseline topography also shows very little cylinder in the cornea. But we're getting a diopter of cylinder in the refraction, so that just means this patient's got a decent amount of internal astigmatism, and that's probably what's causing the problem with the vision. So in this case, what we want to do is, since there is no cylinder to mold out on the cornea, we want to induce a little bit of with the rule astigmatism to counteract the internal against the rule astigmatism. And we might be able to do that by loosening the lens a little bit in the vertical meridian. The more common situation we run into with wave orthokeratology, especially myopes, is not correcting enough of with the rule astigmatism. But in this case, this is the opposite. We actually want to have more of it on the patient's cornea. And so to do that, what we're going to do is loosen the vertical meridian. And this will be in 50% mode. And I would try to go about 17 microns. So right now, we're at a sagittal depth of 728. We're going to decrease that by 17 microns in this meridian. So our new target is going to be 711. I'm going to increase the multiplier to speed this up a little bit. Close. And 711. This is a freeform lens, which is why changing one side didn't change the other side too much. We do have to go down to this side. And 746, 17 micron differential will be 729. And we're at 729. So the simulated tear graph is going to look very unusual in the vertical meridian. We didn't do anything in the horizontal, but that's okay. We're trying to do something slightly unusual to this cornea anyway. I would also increase demand by a quarter diopter, so we're going to go back to 100% mode and bump our power up to about a 1.5. I'm going to go around and make sure the power is pretty uniform all the way around, and it does look pretty good. We can probably tune this one up a little bit. And this one as well. And this one. Okay, so that puts us pretty close to 1.5 all the way around. And with this patient, the last thing I would do is add prism in. So just go to the over refraction box, and we can see here that wave is predicting that the patient's going to have about 3/4 of against rule astigmatism after treatment, and that lines up or corresponds pretty well with what we're measuring clinically. We're not going to enter any over refraction, just going to click the prism box. And see that the bottom of the lens is a little bit thicker now. So because this is such a spherical cornea and there aren't any anatomical markers to really orient this lens, at least when the lens is first put on in the morning or in the evening, it will hopefully orient the way we want it to, because if this lens does rotate 90 degrees, then we're actually going to cause more against the rule astigmatism instead of with the rule, and that will work against us. So this is going to be a little bit tricky because once the patient lies down and posture is different, where is that prism ballast going to go? We don't really know, but this does give us a way to orient the lens when it's applied. And then if you have the lab dot the lens at 6 o'clock, then the patient can also perhaps see a little bit where that lens is when it's ready to come out in the morning. So it's not a guarantee the lens is going to go where we want it to go, but at least it's going to let us know where it has gone if it does move. So hopefully this will put a little bit of withdrawal astigmatism into the cornea and get your patient seeing a little bit better. So those are my thoughts. Best of luck with your case.